Well, then what's going on with aging? I've got two women in front of me, and they have two different colours of hair. Now, let's just pretend, for argument's sake and for the sake of this explanation, that this is someone's hair that's gone grey because of stress. And this is what she used to look like, or he used to look like in terms of the colour of their hair. What I found really interesting, because it kind of speaks to lots of things that are going on in the body, is you're saying you can actually reverse grey hair without dyeing it. And if so, what does that tell us about what grey hair is, but more broadly about stress, energy, mitochondria, and everything in between?
Yeah. What we discovered is that hair graying is reversible. And that was surprising, because what I've learned and what most people learn is that when you age, it's kind of this linear progressive decline, and there's kind of nothing you can do about it. But it turns out that if you look on most people's head, you can see things like this. This is obviously, this was dyed, and all of the hairs were white, and then all the hairs are dark. And if you take a hair like this, the tip here, right, was inside the body long time ago. This is almost like if you looked at tree rings, right? You take a tree and you cut it in cross section, you see like the rings, and then you can say, ooh, this ring was 30 years ago, right? And this ring is today. So you can use that to kind of map the history of what happened in the environment of the tree. You can do the same thing. We all walk around with biological history crystallized in this hair. And that's why if you want to know if someone had a drug, for example, like a month ago or 6 months ago or 2 years ago, depending how long the hair is, you can actually use the hair, and all along would be, the chemical signature of what you took. So you can find marijuana in the hair, here, but not here. So if you have marijuana 6 months ago, it's going to be in your hair, and you're going to walk around with that trace, that physical trace in your body.
I need to get a haircut. I'm joking.
And the idea was, if we could find hairs on someone's head that the tip was dark, right? And then when you look closer to the body, it becomes white, right? And you would say the hair was young, it was young, and then boom, it became old, right? It lost color. Hair graying is a classic hallmark of aging. Then we thought, then you would know that something was happening in this hair follicle in this person's body, right? That made this young hair become old. And then maybe we could understand the mechanisms of the aging process. So this became a kind of an interesting scenario. And through doing this, we found people started to send us hair samples in Ziploc bags, over the mail. And we were looking for two colored hairs, a single hair that has two colors, kind of like this. And we found hairs that, head hair, beard hair, pubic hairs that showed the signature. The hair was dark and then it became white, or the hair was white and it became dark again. Mm-hmm. So we had physical evidence from multiple people that showed white hairs can go back to being dark. And this contradicted this idea that, aging is this linear progressive process that we're kind of doomed to experience without any flexibility. I was one of the participants in that study. I ended up finding 5 hairs that had this pattern. And when we looked at when the reversal happened, we found that the reversal happened when I went on vacation. And I would go back in those days on annual cycling training camps. So I would go for a week where all you do is you bike, you eat, you sleep. Energy started to move very differently in my body during that time. And then when we looked at the hair and we analyzed the composition, the molecular composition, that's what scientists do. You can take a hair like this, snip the pieces, the white segment, the dark segment. It's all the same genome, right? Every hair has the same genome, the same genetic material, same food, same physical activity, same everything. Why some hairs go like this or like that was an opportunity to understand the dynamics, the plasticity, like how life can go from being young to old or old back to young. And what we found was that the main signal was a mitochondrial signal. And in the white hair, I thought there's going to be less color, right, obviously, but also probably less mitochondria, less, some other things. We found that the white hairs have more mitochondria. And there was an upregulation of the body, the hair follicle, where the hair was becoming old, wasn't kind of letting go of things. It was doing more.
So that means during that period of time, you were more stressed and using more energy?
When cells become old, instead of just dying, right? They struggle. And when a cell has damage in the DNA or the mitochondria not working properly, or for some reason they accumulate damage, they become old, the cell struggles to make more mitochondria. And it tries to kind of compensate and then ends up wasting a lot of energy in the process.
So on that hair, what you looked at, that was gray, let's call it. It had more mitochondria because it was struggling. And why was it struggling?
It looks like stress hormones can, make a cell struggle, for example.
Cortisol.
Cortisol, yes. If you're a cell, right, and your perspective on the world is pretty simple, you don't have, the senses that, we enjoy, but you do nevertheless, sense the environment. If cortisol comes and you get the signal, it means there's something out there in the environment that's dangerous, right? You should be preparing for having to fight or to flight, or there's something out there that's dangerous. Our cells evolved to interpret cortisol in that way. So we did an experiment in the dish. We wanted to know how much energy does it cost to worry about the future, right? Or how much energy does it cost to ruminate about yesterday, the thing you didn't do, or the mistake you made at work, or that conversation that went sideways, with your partner. How much energy does that cost to be thinking about this, to be, engaging your stress system, to be releasing cortisol? So 2 students in the lab, Gabriel and Natalia, did that experiment. You put cells in a dish, you give them the equivalent of cortisol. How much energy is going to cost for these cells to prepare? There's nothing damaging to the cortisol itself, but the cortisol is a signal that there might be something dangerous outside. Right? It's like when you're sitting down, you get an email, you're like, oh, I might lose my job, right? Or I might not get this contract. And then you have this whole stress response. Your heart starts to beat faster. How much energy does that cost? So in cells in a dish, we can isolate that question really well. We found that the stress hormone increased energy expenditure, the cost of life, by 60%.
So when I'm stressed, I'm using 60% more energy theoretically.
I don't know about you, but cells in a dish.
Okay.
So the beauty about like bodies and, with the mind and, this complex organism, they're buffering systems, right? So I don't think your energy expenditure increases by 60% if you're stressed out, but it increases somewhat.
What is that graph there?
So there are 2 graphs here. The top one is the color of the hair, of a single hair from a young Asian woman who was part of the study. And what we see here, this is called the hair pigmentation pattern, the HPP, that we developed in the lab to understand quantitatively, bring science to hair graying and reversal. And so what you see here is this hair was dark, and then it became white for 2 centimeters, and then boom, completely regained color. Actually, it was darker here than it used to be. Right? And then stayed dark afterwards. So this is a hair that we received in the mail as we were starting to collect 2 colored hairs. And then when we saw this, we had found from a few different people white hairs that had regained color. We'd never seen a hair like this. That's dark, white, and then dark. Right? So I remember holding this hair. I was like, oh my God, this is in the same hair. This was incontrovertible evidence that graying of hair is reversible, and it can be pretty fast. Like this transition here is just a few weeks. This is about 1 week, right? So this white hair, completely white, regained color in just about a week. So then we developed an instrument, which was a simple sheet. On the y-axis, the vertical is most stressful thing that ever happened to you, no stress at all, 10 and 0. And then the x-axis, the horizontal, was time. Yes. On the far right is now, right? This is now, this is a year ago. And then we labeled all the months. And then we asked people, and we asked this lady, put a dot on the graph that was the most stressful time in the past year. That anyone can do the exercise, past year, most stressful time. Okay, maybe last March. And then you put a dot, right? And March, number 10. And then least stressful part, 0. And then put other like meaningful things that happened that were challenging. So people put dots, along this last year, then connect the dots, right? The red graph is her dots connected.
And it correlates perfectly to her hair going gray.
Correct. And what happened to her life, she said she finished her PhD thesis and she was jobless, but she was fine. She was happy to be done with her studies, and then broke up with her boyfriend.
Oh, damn. And her hair went gray.
Yeah. broke up with her boyfriend. She didn't know what was happening with her life. She had to travel to Europe. There was some family drama. She said these were the most stressful 2 months of my life.
There's a killer question here, which is, if that remains chronic, does that hair follicle go grey forever?
Yeah.
I.e., if I go through a stressful period for 2 to 3 weeks and my hair goes a bit grey, as long as I get out of that stressful period as quick as possible, does that hair then return to black or dark?
Yeah.
Do you see what I'm saying
Yes.
here?
It seems like, and we ran some like fancy mathematical model to understand why this would be possible, why it could happen like now for this hair and then be reversible. But we know, very well, if you have a full head of gray hair and you're 70 years old, you're not going to regain your color.
Yeah.
So there seems to, what the mathematical model suggested is that there's a window of opportunity, right? Where a hair slowly accumulates damage, becomes more and more probably energetically inefficient, right? So there's more and more energy resistance, and then there's a barrier. And then when the hair hits that threshold, now it loses color.
It's done.
Yeah. But then if something changes in the body, right? You go on a vacation or you start to do intermittent fasting and then there's more energy available for your dark hair. Now it can be reversed, right? Because you can go back up against that threshold. But then eventually this hair is going to go gray again. And then if you're way, way down, like this hair turned gray 10 years ago, and you go back up, you're too far away from threshold to regain color.
Okay.
So it suggests some threshold model that there's a window of opportunity for something as binary as hair color. It's black or it's white, right? So there's kind of a window of opportunity there where
you can reverse gray hair.
Yes.
I do want to come back to this hair thing, but it did make me think, because you added a layer of nuance there, which is about the mind.
Mm-hmm.
Like if I go through my life with a more resilient mind, and you get that bad email and you go, and I get the bad email, I go, fuck it, who cares?
Yeah.
Am I therefore going to be a way more productive person throughout those 24 hours because my mitochondria are using less energy because there's less cortisol?
Yeah. Based on what we know, I think that's likely correct. So it's not the stress that burns us down. It's the response to stress. And nothing is free in biology. And for your heart to beat a little faster, if you mount a response to that email, right, you're burning energy in your heart. And then you're tensing your shoulder. That's burning energy. Now your brain is going into like rumination mode, and then this thing, and then it makes you think about your childhood and this, and then the anxiety, and then you start to sweat. Like everything costs energy.
So the chain of events is, I get the email. It's a very bad email. It says, "You're fired, Stephen, from the Diary of a CEO. We found a different host."
Yeah.
I look at the email. That goes into my psychology, my mind. I then have a story I tell myself about what that email means for me, my future, my children, whatever, which then causes a physiological response of like chemicals like cortisol, which goes into my cells, my mitochondria, which then have to work a little bit harder or use more energy, which is ultimately then going to mean that I'm more tired because I have a finite amount of energy per day. Is that sequence of events? I ask about that sequence because it offers me an opportunity to intervene at some point.
Yes. Yes. That's the right way to think about it.
Don't open the laptop. Or like get a little bit better with bad news.
Yeah. Or, learn to be less reactive, right? Or learn to feel and sit with, be aware of that reaction. Because the key solution to kind of to cutting that sequence of event that ends up draining you is to become aware of it.
Yeah, become aware of it. Yeah.
Right? So you can kind of interrupt this. And people who study contemplative practices and meditation and mindfulness approaches, I think many of them think this is kind of the key, right? The awareness, the somatic awareness or interoception. So if you feel into your body's responses, you become free of, do I mount a response? Is that needed now or not?
There's different types of stress, right? There's like the acute stress, which is just, you get the email, you feel a little bit of a spike, but 5 minutes later, you're fine.
Yep.
And then there's the more chronic type of stress where you're waking up every day with the same feeling of stress deep inside you for many, many days in a row, many weeks in a row.
Yeah.
I hear that acute stress isn't all that bad and it's very normal and useful, but it's this chronic stress that can cause a lot of damage.
Yeah. And I think that brings us back to the concept of how is energy flowing through the body? And if it flows with not enough resistance, you can't survive. But if there's too much resistance, then you get drained.
How do I think about this resistance thing? Because I'm really struggling with like understanding it.
maybe one good example to frame this is exercise.
Yeah.
Right? When you start to exercise, there's increased resistance in your muscle, right? Your muscles are contracting. So there's a physical resistance there, but there's also energy resistance. So the energy is trying to flow through the muscle, and then you have mitochondria. If you have just a few mitochondria and the muscles are contracting really hard, like you're running, you're sprinting, right? You're doing interval training. Now the mitochondria don't have the capacity to flow as much energy as the muscle is asking. Right? So that imbalance of demand to flow capacity. Now the product of this, the demand divided by flow capacity, is resistance.
Okay.
So if you demand a lot of your muscle because of your sprint, but you don't have a lot of mitochondria, right? It's going to feel terrible. And then because the resistance creeps up, and then your muscle, becomes really hot, and then eventually there's inflammation, and then it burns, and then it's uncomfortable. So that's like an acute bout of energy resistance. What happens with exercise is once you recover, right, the benefits of exercise don't happen during the exercise; they happen during the recovery. So if you recover, now the muscles are relaxing and you're resting. Eventually, you go to sleep. It's during the decrease in the resistance. Now the cell says, next time this happens, I better be ready. Like this was really uncomfortable. There was too much energy shoved into a system that couldn't take it. Right? So I'm going to make more mitochondria. So that's what happens if you go from being a sedentary couch potato, right, to training for a marathon. You can double the amount of mitochondria you have in your muscles. And that's the system feeling the rise in resistance, like I don't have the capacity to flow that much energy, and then adapting for this for the next time. And said, next time I'm going to be ready, let's make more mitochondria. So that's probably where the benefits of exercise come from. This spike in and why stress is not a bad thing intrinsically, right? If you have a spike of stress, it stimulates the process, it stimulates the body to put in place things that in the long run makes you more efficient, decreases your resistance. Then you can go through life with less resistance.
Coming back to this grey hair thing. So if we consider grey hair, my hair going grey, to be the last domino that fell, so like the symptom,
yep,
then what is the first domino? Mm-hmm. And can you walk me through the sequence of events? Because one would assume that if I understand that sequence of events, I can also understand how to then reverse it. Yep. How to kind of I got a couple of grey hairs now. And I actually anecdotally do think, weirdly, now you've said this, that I have like grey hair flare-ups where I'll go through a couple of weeks or months of doing something and I'll look in the mirror and be like, what? I have 12 now? I'm being generous there. There's more like 25. I have 25 now. In terms of those dominoes, the symptom is grey hair. Yep. What is the first domino that falls? And what is the sequence of events that leads to the grey hair in the follicle? So
there's a finite energy budget. Mm-hmm. And then what the organism does is it allocates energy in different places, like a business, right? You have this budget. Do I put more energy here? Do I put more resources here? If so, I need to take resources away from here, right? So as stress happens in your life, it pulls energy away from some of the things that keep you young, right? So there's a kind of a hierarchy of energy needs in the body. Not everything can be prioritized the same way. You know Maslow's hierarchy of human needs?
Yeah.
So Maslow's insight was,
oh my God, I just freaked out. My hand reached down and I just felt someone's head. It was just,
acute stress response.
Yeah, cortisol fled. Sorry, Maslow's hierarchy of needs.
Yeah. So there's a hierarchy of energy needs in the body that works similarly to Maslow's hierarchy of needs. Maslow said, for a human being to be fully realized, first, you need to have safety and food and shelter secured, right? Once you have this and you feel this is kind of covered in your life, then you can start to think about building relationships with other people, right? Loving relationships. Once you have this settled, now you can start to think about building your skills, right? Like becoming really good at something. And then once you have this covered, now you can devote energy to the more frivolous things like spirituality, what you call self-actualization, and kind of becoming your best self, flourishing. So he saw this very much as this needs to be covered. And when things get really hard and there are constraints on your life, the first thing to go is the top of the pyramid, right? Your meditation practice or the long-term type, like I'm going to be a better person. No, like I need to make sure we can put food on the table next week, right? So this hierarchy of human needs, I think, aligns with hierarchy of energy needs in the body. And as far as the importance of hair color goes, it's pretty low on the hierarchy. So as the body gets older and you have more and more cells in the body that start to be less efficient, right? Their mitochondria are working a little, less efficiently, and then there's more inflammation in the body that's costing energy, and there's more worries about professional obligations, and all of these things kind of stack up and steal energy away from the things that are there. We call them growth, maintenance, and repair. These are like the anti-aging processes in the body, and those need energy, but they're not as important as facing the stressor that you think is life-threatening now.
So if there's a lion chasing me, my body's going to commit all the energy I have to getting away from this lion, and it might say, listen, Stephen, we're not going to repair the skin next to your eyes. You're going to get a couple more wrinkles, and we're not going to commit energy to making sure your follicles in your hair produce black pigment or whatever.
Exactly.
So I would then look aged. I would look older. But that's because all of my energy's been going to something else, which my body considered to be a higher priority.
Correct.
Which also brings me to, I guess, the famous, what we always talk about with presidents, because presidents go into office often with dark hair and they come out with grey hair. And usually one does not age that quickly in 8 years. We see the same in the Premier League with football managers. Mm-hmm. They walk in on that first day, they look very sprightly and energetic. And 2 years later, they have grey hair, bags under their eyes, wrinkles, and they look like they've aged 10 years. Yeah. So you're telling me actually that the real secret to anti-aging, if there was one, is
the proper allocation of energy.
If you love the Diary of a CEO brand and you watch this channel, please do me a huge favor. Become part of the 15% of the viewers on this channel that have hit the subscribe button. It helps us tremendously, and the bigger the channel gets, the bigger the guests.